Hello class, welcome to our last StatTutor 19.2 monthly premiums of auto insurance. You are almost done with StatTutors and the class. Okay, so let's do it here. Item number 1 is going to be a linear model regression line. We've done it before. What's new is we are going to look at the inference, so we'll have the p-value. Okay, and then number 2 is a t-test. That's the big picture. So going in for question 1, this is the auto insurance data. Let's take a look at it. We've got experience, that's number of years in the policy. Gender, let's see, 1 is male, 2 female. I'm forgetting. Take a look here. 0 is male, 1 is female. Okay, 0 is male, so I got 3 ladies here. Premium is dollars per month. Awesome. So exploratory analysis, we want to look at experience as explanatory, premium as response. So we're going to plot that. And you just use the standard format. X goes in the first position, Y goes in second position for a plot. X and Y. We see there is a moderate level of negative linear correlation. So let's click on the run button for correlation. Again, it's the same form. You put your X first, your Y second, same as the plot. There's an optional argument here, use equals complete. We need that if there's some NAs. There weren't in this case, but I put it in there for good practice. Okay, so we've got an observation. Now let's run the linear regression. Let's see what the best line through that is. You can tell it's going to start up here somewhere, maybe up in the 70s, 80s, and then it's going to have a negative slope. So the format for the linear model is LM, and then it's Y with the tilde X. Response by explanatory. It's the same format for box plots, and we've also seen how to use the mean command with the mosaic package for that. So let's do that. There it is. Now out is actually the result. This is the y-intercept. This is the slope. Okay, as we said, it's in the 70s and it's got a negative slope there, so that's looking right. Here is a statement of the regression line, if you want to put that there. And to put it on the graph, the command is AB line. We saw this early in the course. Notice, oh, the line pops right up there. That's awesome. And then what we want to do is look at the regression output. So is it a statistically significant slope or not? We do a summary on that linear model. In this case, it was the object out. And so there we go. Got a lot of output here, more than we need to worry about everything. This just tells me what the function call was. These are the residuals. That is the vertical distance of each point from the line. So this tells me that the median residual was minus 0.8 off of the line. That's in terms of premium dollars per month. So that's 84 cents off on average, these points are. Okay. The largest one was 22 bucks off, and above, this one was 22 bucks and below. Okay, that's residuals. Coefficients here. This is the intercept, this is the slope, and these represent the statistics on those for the hypothesis tests. So the first one is a hypothesis test on the intercept. The second one is a hypothesis test on the slope coefficient. Here's the p-value. That's the bottom liner for what we want. We want that 9.79 times 10 to the negative 5. And again, that's going to be 4 zeros and a 979. The fifth zero is right there. Okay, way below a 0.05. Therefore, we reject the null hypothesis of no slope, and we conclude, yes, indeed, the slope that we're seeing there is statistically significant. More experience, lower premium. It's a real phenomenon in the data. Okay, let's go to question 2. Do males have higher premiums than females? This is something everybody's interested in. It affects me. I guess if you get married, you kind of balance one another out, one way or the other. Here's a box plot, and we said that males were 0. Looks like they are higher by the eyeball. So let's test it. Okay, I'm going to run my mosaic library. I already had that in. This is clogging up the line there. So the mean, 69 versus 54. Wow, $15 difference in the means. Median, it's an $18 difference in the medians. Okay, and the standard deviation, looks like the females have a little higher variation there. Interesting. Now we come to the formal test. The format for the test, it's the same y tilde x as in the box plot. I've got that popped in. We recall the other arguments. There's the mean argument, that's the null hypothesized value, which we always do 0 for independent t-tests, so that's what it is. The null hypothesis is that the mean of one group equals the mean of the other. In other words, their difference is 0. And the alternative, we're going to do a greater than because we're going for the guys bigger than the gals. Depending on how the variables were scored, you might need to do a less. So let's demonstrate that. Here we run the greater, and this is correct. The 0 group is higher than the 1 group, and so greater is right. There's the p-value, very small, as we suspected with our eyeball. We conclude that there is a statistically significant difference between the males and the females. The males spending quite a bit more on average. Okay, what if I ran that? That's up arrow, and I had less. Let's just take a look. Notice the p-value is the complement of the other one. It's just the other side of the curve. Okay. Yeah, I don't have it, but if you had a big old curve here like this, then we're looking at the far right-hand side, which is a teeny weeny little bit, versus the whole almost curve. That's what this one gave. Okay, so of course the first one is correct, and that's what we want. Males do have a higher premium. Okay, that's a wrap there. So hopefully that you found the syntax to be relatively simple, and the number of commands did not grow much during the whole semester. Now you'll need to employ these in your projects. May God give you wisdom in that and a great time exploring your data. God bless you.